I'm now recording my broadcast. All right, so the last couple of streams that I did were on DMVPN, and when I say couple of streams, it was like 500,000 individual little streams of me hating myself and life, studying DMVPN tunnels, and then IPsec after that. I went ahead and finished up IPsec on my own because it was getting really tedious, and I figured, while I was feeling the motivation, I'd finish it up. So I did. So anyway, today we're going to talk about prefix lists, which is quite possibly, and I say this with every chapter, but quite possibly the most boring subject in this entire book. So I'm really sorry, but it is on the test, so I have to study it. I'm really hoping that the chapter's not going to be too brutal and it's not going to throw anything crazy at me like, hey, by the way, here's this way that prefix lists work that you never knew before. Surprise! That would be horrible. But I feel like that has been my entire existence while studying for the CCNP, so we'll see. Too many words, I can't read it all. That's okay. Maybe I should, when I make it really small, people say they can't read it, and I assume that they're implying that they want to read it when they say that, so I made it bigger, but now there's a lot of words. It's okay though, because you know what? I'm gonna read it word for word to you anyway, even if you can't read it yourself. So this is the part where I read directly out of the book. So get comfy in bed, fall asleep. Ready? Oh God, yeah, oh, by the way, one more thing. This chapter isn't just on just what prefix lists are, but how to troubleshoot them. So I assume we're gonna have some like fake troubleshoot tickets in here at some point. We'll find out, I don't know. Although an ACL, and by the way, I'm assuming everyone knows what an ACL is. I'm sorry. That's earlier in the book and I just don't want to talk about it. Although an ACL can give you extremely granular control of the traffic you want to match, it doesn't help you identify routes based on a subnet mask. Therefore, ACLs don't give you granular control when matching routes for route filtering. This is why prefix lists exist. They allow you to define the route and prefix that you want to match. This section explains how to read a prefix list so that when you're troubleshooting features that call upon a prefix list, you'll have the ability to eliminate the prefix list as the cause of the issue or prove that the prefix list is the cause of the issue. All right, so straight up troubleshooting. Okay. Note, Cisco Press says, this discussion applies to both IPv4 prefix lists and IPv6 prefix lists. Oh yeah, they work the same, except with the inherent differences between v4 and v6, they work the same. And that's what they're saying here. So all the examples are going to be based on IPv4 prefix lists, but that's only because I guess it's easier or whatever. But v4, v6 doesn't matter, they work the same. All right. So true to Cisco Press style, we have a description of a diagram on one page with the diagram on the next page. So we have to read the description before we see the diagram. But apparently, this is basically just commands used to create your simple prefix list that they're calling NRC. And then after that, they're going to show us the output of show IP prefix list, which you can use to verify your IPv4 prefix lists that are configured on a router. If you were going to be doing an IPv6 prefix list, you just add v6 after the IP in that command and you're good to go. So here's our config. Good Lord, I have no idea if this is readable. It looks big enough to me, but I don't know. IP prefix list and NRC sequence such and such, deny such and such. Okay, so prefix list, this gets me a little confused sometimes. I think it's probably fairly simple overall, but for some reason my brain just sometimes wants to short circuit whenever we're talking about the different ways that entries in prefix lists work. You have a couple of different ways. So for example, this line right here, and I'll read all the crap that they say below, okay, but this is part of me learning. So deny 10110/26, it's literally just a match on that network, that subnet. So this prefix is going to be denied, anything that falls under that. Bim bam boom, easy peasy, we're done. But with a prefix list, you can also get more granular. So this LE right here on the next line, we have a permit statement, and just like above, we do have, you know, an IP address and a subnet mask, but we have LE and then the number 32. So this is the second way that prefix lists work. Less than or equal to is what LE stands for. If it were GE, which is the other option we could use, that's greater than or equal to 32. Or whatever number you choose to put after this, right? The idea is that this section right here is talking about the subnet mask. But let me actually just read what the book says so that I don't like just go totally off script. There are two different ways to read a prefix list entry, depending on whether there's an LE or a GE. All right, so no LE or GE. That just means we're treating it, like I said, as a subnet mask and an address. That's it. So this is matched exactly. 10110/26. We'll skip the rest of that paragraph because that's basically it. If there is a GE or an LE, the prefix is treated as an address and a wildcard mask instead of an actual subnet mask. So we're defining a range of values here. So if I don't think I can get both of these things in the same without having to scroll down, but the /24 is our wildcard mask. So it's seeing, you know, basically the first 3 octets. 8 times 3 is 24, 8 bits, 8 bits, 8 bits. The first 3 octets have to match 10, 1, 1. But then after that, the last 8 bits can match anything, which means that we have a range from 10110 through 1011255. This is going to permit any address from 10110 to 1011255. But also we have that added little benefit of less than or equal to 32, which just means anything that falls under a subnet mask less than or equal to 32. So basically 10110/24 all the way through 10110/32, anything under any of that is going to work, is going to match on that permit statement. I'm saying this really inelegantly because my brain's also working to catch up. So they give us these easy examples, right? 1011/24 will be permitted. 1011/64/26 also will be permitted. 1011.128/30 also permitted. We can only have up to a /32 subnet mask, so this is permitting any subnet mask, basically. Less than or equal to 32 is every possible subnet mask. Now, this part interests me, and this is something that I wanted to look up and completely forgot about before I streamed this. We have a third entry here that permits 0000/0, quad 0/0, which is typically referred to as a default route. What the book says, this is how Cisco Press puts it. I'll just read it word for word. Because there is no GE or LE, it will be an exact match to the address and mask listed. In this case, the address and mask are quad 0/0, which is the default route. Therefore, if this prefix list is being used to filter routing updates, the filter would permit the default route. Okay, I might be stupid. It's very possible I'm just stupid, but that doesn't make any fucking sense to me, okay? Like, it permits the default route. What the fuck does that mean when you're talking about a prefix list, right? So I'm assuming, I'm pretty sure I'm right, but of course I'll have to look this up later, that what they're actually saying, or what the actual meaning of this is, that any address at all, any subnet will match here, will be permitted, I think. Now, if that's true, it doesn't this whole thing doesn't make sense, because why would you have like a deny statement after you've permitted everything, right? But, you know, this is just an example in the book, so maybe that's the reason. But I'm pretty sure quad 0/0 is just going to permit like everything. Because if you think about it, right here, you know, we've got a /24 address, right? And that /24 is telling us that 3 sets of 8 bits have to match, and then everything after it doesn't have to match. So if we've got a /0, then that just tells us that nothing has to match at all. So I don't know, it makes sense to me. I don't know why they're phrasing it as the filter permits the default route. That's such a weird way to phrase it, but maybe I'm just thinking about it weird. Anyway, it's fucking weird. Moving on though. So they're talking about sequence 35. So I think this is the last one. If we scroll up, yeah, our last sequence is this last one right here. The deny statement for 192.168.00/20. And then they get, okay, so this gets a little more complicated, right? Greater than or equal to 24, but less than or equal to 28. So any subnet mask between 24 and 28, which is, 5, 6, 7, right? Or I guess it count, it's greater than or equal to, less than or equal to. So it's 24, 25, 26, 27, 28. Any of those subnet masks will be matched. Other than that, yeah, nothing else will be permitted. So hang on, let's see. Yeah, they cut this off. So because there's a GE or LE, the address and mask are treated as an address and wildcard mask to define a range. Therefore, the 192.168.00/20 is actually, that's our wildcard mask, the /20, right? So that's going to translate out to 0015.255. And that's just, I don't want to get into the specifics, but that's how the bits lay out, right? If you've got a /20, you've got in the first 2 octets, you got 16 bits total. And then you have to add 4 more in order to get that 20. So that's where our 15 comes from right here. And then of course, 255, 255, or sorry, 1, 255. So this whole thing with the wildcard mask is basically defining a range of 192.168.00 all the way through 192.168.15.255. That's the max that it can be, is at that 15.255 because of our /20. That's what we're talking about with a wildcard mask. But then of course we've got the greater than or equal to 24, less than or equal to 28. So of course that's what's defining our subnet mask. And so if a prefix entry is used, if this prefix entry specifically is being used to filter routes, all routes between that 192.168.15.00 through the 15.255 range with a subnet mask of /24 all the way through /28 will match on that entry specifically. Anything else that doesn't follow both those guidelines, the range that the wildcard mask specifies and the, I guess, range that the greater than or equal to statement specifies as well, it's not gonna work on that entry. Now it's your turn. Which routes will match the following prefix lists? Put me on the spot. Well, I was in the middle of talking about prefix lists. To continue what I was chatting about, we're practicing, here we go, zoomed in a little bit. We're practicing interpreting prefix lists. So I was just about to finish figuring out what this means. And I'll just start over from the beginning because it's not like, I'm just so frustrated with the state of RPAN Studio, but I'll let it go. I'll let it go. I'll breathe. And I'll probably just migrate to Twitch because right now I'm not streaming on Twitch because it's way too complicated to do and I'm very lazy, but I'll probably migrate to Twitch here pretty soon. Anyway, all right, IP prefix list example, permit 10110/24, greater than or equal to 26. Super fun. So to go back to what I was saying, 10110, that's our subnet. The /24 is in the case where we have a GE or an LE, it's really more like a subnet mask, or I'm sorry, it's really more like a wildcard mask than a subnet mask. So the GE and the number that follows it, that's going to be our subnet mask. So which routes match the following prefix? 1011.0. So the /24 is basically telling us that the first 3 sets of 8 bits, the first 3 octets as we call them, 1011, they have to be the same. So the range is going to start with 1011. And because it cuts us off right here exactly equal at that last, after the last 8 bits, at a /24, that means that any of these following 8 bits can be anything. And with bits and subnetting, we can go all the way up to 255. So that means that this /24 is just telling us it's going to be a range of 10110 through 1011255. Our subnet mask will match on anything that's greater than or equal to 26. So we can have 10110.10/27. That'll work. 1011, sorry, did I say 10110 dot something else? 1011 dot, 43/28/29/30/26. Anything that starts with 1011 and is through 0 to 55 or 0 to 255 at the end with a subnet mask that's 26 or higher, that's going to match. Easy peasy. Because there is a GE, yeah, okay, so they're explaining everything here, right? So because there's a GE, the /24 is treated as a wildcard mask. It's our 00255. Therefore, the range of routes is from 10110 to 1011255. All right, I'm not going to go over it because it's literally the exact same thing I said. Because I know my shit. All right, so now they're going to review with us how prefix list processing works. When do you get to bring the corporate DNS servers down? I knew there would be Facebook comments today. I knew it. Oh man. We don't get to do that till we're at least like a level 100 network engineer. Okay. Prefix lists. They work just like ACLs with the top-down processing. So you go entry by entry from the top to the bottom every time. A prefix list is made up of various sequences. These sequences are processed from the top of the prefix list to the bottom of the prefix list in order of sequence number. So if you saw maybe above, as I scroll. So when you're configuring a prefix list, you're defining the sequence here. Seek 10, seek 20, seek 30, etc., etc. So it starts at the lowest number and it goes down. So if you're configuring it out of order, I think it works this way with prefix lists. I think if you configure it out of order, you just specify the number and it'll put it in order for you. So it's going to go down that way. That's step 1. Step 2. These aren't really steps, are they? They're just like bullet points, really. But whatever, Cisco Press, however you want to format it. Immediate execution upon a match. So as soon as, a subnet or whatever, as soon as a prefix matches an entry in that prefix list, then you're done. It's not going to keep processing. It's not going to go down and try a permit or deny for anything like that. It's going to stop at that one entry that it matches because all it needs to do is match one entry and then you've got your action and you're good to go and you're done with it, right? So it doesn't matter if there's another sequence later in the prefix list that matches, only the first sequence that matches matters. So they give us an example. In our earlier example, the 10110/26 network falls within the range defined in that sequence. Let me scroll. Oh God, let me zoom out and then scroll up. It helps a little. So they're talking about this entry right here, the very first entry in our example prefix list that they so lovingly call NRC. IP prefix list NRC sequence 10 deny 10110/26. If we had 10111, 1/26 come in, then bam, that matches. It's not going to keep going through all the rest of the entries down here. That's it. We're done. That's all they're saying. Scroll out again, scroll back. All right. Step 3, or as I would rather say, bullet point 3, because it's not like these are actual, I guess they're steps, but whatever. Anyway, implicit deny any. So at the very end, we have an implicit, as we call it in ACL land, Implicit deny all is the same thing. Implicit deny any. If there's no matching sequence, the information is automatically denied based on what we're calling the invisible implicit deny any entry at the end of a prefix list. So just like an ACL has that, a prefix list has that as well, where if you have a subnet or a prefix that comes in, it doesn't match the first entry, the second entry, the third entry, there's no matches, and then you get to the end of it, there is an implicit and implied deny all traffic at the end of it. It won't be visible unless you specifically configure it, but it's there. So if you don't configure anything in a prefix list or an ACL and you just throw it onto an interface, it's going to deny everything until you start permitting stuff in there. So that's worth knowing. Because there's an implicit deny any at the end. Okay, sorry. I go off script and I say these things and then they say the same thing in the next paragraph. So I apologize. Although this denies, let's see. So we have an example that they give us. If you're creating a prefix list to deny a specific route or two, so for example, if we want to deny 10110/24 and 10120/24, we can create the following entries. The commands in order would be IP prefix list name sequence 10 deny 10110/24, and then our next one would be IP prefix list name sequence 20 deny 10120/24, right? Although this denies both prefixes, it also denies every other prefix because of the implicit deny any at the end. Therefore, to permit everything else, we actually have to include an entry that permits everything. The following entry would do just that. And they answer my biggest complaint that I had earlier, which was that they were saying something, they were wording things really terribly with permitting quad 0/0. So this is the entry that would permit any prefix that comes in to the interface or whatever you're setting this prefix list to. This would match on everything else, right? If you're using this to filter traffic in that way. When are you going to hit something with a wrench? We're in short circuit. I guess people probably do that in here, but I'm not. Network engineers aren't always super hardware. Mechanical engineering. Yeah, thank you. I hit things with silicone chips. Yeah, sorta. I hit the keyboard with my fingers and things happen. That's really what it is. All right. Then they give us a little key topic. Don't confuse the, oh, god damn it. What the hell, Cisco Press? Do not confuse this with the default route entry sequence 30 from our earlier example. That doesn't have an LE or GE, and this example does. Ah, so they didn't actually answer my question here. Let's review it. The LE indicates an address and a wildcard mask. So quad 0/0 is really quad 0, 255, 255, 255, 255. Therefore, the range is all / any address. The subnet mask is less than or equal to 32, which is 0 to 32. Therefore, this entry permits all routes. The IPv6 equivalent is what follows next. So that's the same thing, except it would be IPv6 prefix list, name, sequence, whatever, permit, and then you've got the :/0, which is the same as like a default route for IPv6, less than or equal to 128, because that's how IPv6 works. Huh. Quit hitting me with stop it with the clever comments. This section okay, hey, I called it. We are going to have trouble tickets here. All right. Hooray. It's going to be fun to listen to me like narrate these out. I'm sorry in advance. Okay. Blah, blah, blah. Various trouble tickets relating to the topics discussed in this chapter. The purpose of these trouble tickets is to show a process that you can follow when troubleshooting in the real world or in an exam environment, because those are the same. Oh, Cisco. Okay. Our first trouble ticket. Here we go. A user, I hope you can see this diagram okay. That's the main reason why I started streaming like anything from the book, is just so that we could see diagrams instead of just me sort of talking at the screen. So PC1 right here, our issue is that the user at PC1 can't telnet to 192.0.2.1, which is over here in this little cloud area. However, he can ping it and access web-enabled resources. So telnet and web-enabled are kind of our keywords there. So it sort of sounds like we might be not allowing, like have an extended ACL maybe somewhere that's not allowing telnet traffic specifically, but is allowing web stuff. So like port 80. We start by verifying the problem. On PC1, we try to telnet just like the user says, and of course it fails. So we have that sort of example down here. We've got the output of us trying and failing to telnet. This over a little bit. Could not open connection to host on port 23, connect failed. Okay. You then ping 192.0.2.1 and we can see we do get pings back. It's nice and cut off like we like it, but it's there. So 0% loss with ping. Okay. So at this point, you should be thinking that the issue is related to either the telnet service being disabled on the host at 192.0.2.1, or it could be an ACL. Why an ACL? Cisco Press asks us, as if the answer is not because the trouble ticket was labeled ACL trouble ticket. Certain types of traffic are allowed through, but others are not, and this is accomplished with filtering. Okay, so this is how we can, I don't know, understand, what's the word? What is the word I'm trying to think of? Whatever. This is how we understand, this is how we, as we suss through it, this is how we're making sort of a logical leap to, this is probably an ACL, based on the fact that not all traffic is denied, not all traffic is having trouble getting there. We can ping it. It's just specifically telnet that's having the issues. That's what makes us think maybe it's an ACL. So first, verify whether there are any ACLs configured on R1 that are filtering telnet related traffic. So if we go back to our example, and here's where I need to take a little snippet of this. Okay. That's not showing on the screen. Hang on. Oh, it is. It's just really, really big. Hang on. Sorry. There we go. Let's bring you up a bit. Here we go. Cover my face. There we go. Hopefully that's at least a little bit readable there. Okay, whatever. Okay, so I'm gonna scroll down to our actual issue on the next page. All right. So we're starting at R1, right? Because where's R1? Where's my little pen? We're starting at R1, the only router in this picture, conveniently, because that is our first hop gateway, and that's as good a place to start as any for this kind of issue. So we're going to look and see if we have any ACLs that are blocking stuff. Show IP access lists is the command that we're going to use to do that. In this example, there's one extended IPv4 ACL identified as number 100. So God, so they have all this, sorry, they have all this explanation here. I'm trying to scroll down so we can actually fucking see it, like what they're talking about. Okay. Here's the output. Before I read any more of what they're saying, here's the output of show IP access lists on our first hop gateway. Okay, so we have, looks like 6 entries in this thing. Yeah, 6 entries. We've got a permit TCP host 192.0.2.1 host 10.1.1.10 equals telnet. Okay, so this is specifically permitting just the address 192.0.2.1, just that device, no others, to the specific device 10110, or sorry, 10110 telnet traffic specifically. So if we're on that 192 host, we could presumably telnet to this 10110 host. Now, if you remember the issue that we're having, it's that 10110 can't telnet to 192.0.2.1. So maybe we already see our problem right here, right? Yeah, and they're actually pointing that out to us here. Read it again and think about how traffic is flowing. Okay, so yeah. So the first IP that we've got here is our source, and the second is our destination. That's how we know that it's from 192.0.2.1 to that 10.1.10 address, meaning that's not what we need. We don't need a telnet from 192 to 10. We need a telnet from 10 to 192. So we're out of order, basically. They keep going. How far are they going to go? Yeah, okay. So they go on to explain a little bit more about how the ACL is going to work in this like weirdly configured state, right? So this entry where it's from 192 to 10 looks like it's what's supposed to have the permission for 10 to telnet to 192, but it's just backwards. The reason why it's not working, first of all, is because that entry doesn't actually match on it. And then, so because it's not a match, our traffic's, our prefix is going to keep going down the list. So the second one is deny TCP 10.110.00063 any equal telnet. So that's basically telling us that any telnet traffic from, it looks like from the subnet where 10.1.1.10 is located, any telnet traffic from there going anywhere is going to be denied. So because our telnet from 10 to 192 didn't match that first statement, and then it's going to match that second statement, it definitely is, but the second statement is a deny statement, we're screwed. The traffic is blocked, right? It's dropped. The best way to fix this, says Cisco Press, is to remove sequence 10 and replace it with the correct entry. So remove that backwards entry and redo it, right? So we can use the named ACL configuration mode to accomplish this. Here's how we do that. So there's different ACL configuration modes, by the way, and one of them is called named. Whatever. Have you passed what you're studying for yet? No. Why would I be studying for it if I had passed it? No, I have not. I'm anticipating failing it on the first try as well. Needs more firewalls. No, it does not. Not this example. Have you tried turning R1 off and back on again? That's a good one. Okay, so you're still seeing a pixelated mess, huh? I'm sorry. I don't know what else to do. I zoomed in as much as I possibly could without making it horrible. All right. So here's what we're going to do. We go into named configuration mode, which just means we're going to say IP access list extended and then the number, which doesn't really make any sense to call it named configuration mode because it's not a name, it's a number, but whatever. Then in order to get rid of that 10 entry, that first entry, sequence 10, we just say no 10. I didn't know that actually. I don't really know what I was thinking we were going to do. I thought it would be like no IP access list sequence, blah, blah, blah. But I guess that just shows my weaknesses in name configuration mode for access lists. Anyway, no 10, and then we redo 10, the next line. So we're going to say 10, permit TCP host, 10.1.1.10, host 192.0.2.1 equal 23, EQ 23, which is telnet. End. Boom, we're done. Then if we do a show access list again, we can see that it's back and it's good. Host 10 to host 192 equals telnet. And then of course we got to verify it by trying to telnet from PC1, our 192 host, or I'm sorry, PC1, our 10 host, to our 192 hosts in the cloud. And there you go. It works. You can also, when you run show IP access list, see the number of matching prefixes that have gone by for each entry. If you just run show IP access list, it'll actually show you. So we can actually see if we, after we telnet successfully, we can actually run show IP access list again and see we've had matches on that first one. And on the second one too, from before. So cool. All right, we're on to another trouble ticket. Dear God. All right, here we go. Let me take a snippet of this too while I'm at it. There. Okay. Give me 1 second. Cool. Okay. Trouble ticket number 2. Ooh, IPv6 ACL. Hooray. So a user at PC2 has indicated, so PC2 is down, if you can't see it very well, PC2 is, let me circle it. It's down on the left-hand side right here. I've circled it in red. Okay, so PC2, it looks like its IPv6 address is all of this, except instead of :1, like the default gateway says, it's :20. Just FYI. I'll just call it the 20 host or something. I don't know. Okay, so PC2, :20, has indicated that she is not able to telnet to :7. And this is a totally different subnet. It's just like, I'm not going to read out the entire IPv6 address. However, she can ping, okay, so she can't telnet to :7, but she can ping :7 and receive DHCP related information from the DHCP server. So :7 is the DHCP server. It is up here. Okay. So this is our path right here between those two. Okay, so we can ping 7. We can't telnet. And she receives DHCP. So again, it seems like it's a specific kind of traffic that we are blocking, which tells us there's probably an extended ACL doing some bullshit. So we start by verifying the problem. On PC2, we do the same thing that she says she can't do. We try to telnet to :7 and it fails. So we verify that there's a problem. Then we verify that we can ping it just like she said, and lo and behold, no packet loss, we can ping it. Cool. What could allow pings yet deny telnet? Asks Cisco Press, as if we didn't just do that in the previous ticket. At this point, you should be thinking that the issue is related to either the telnet service being disabled on :7, which, yes, fair, that could be the problem, or an IPv6 ACL filtering traffic into or out of an interface. Again, just like the previous ticket, this is because certain traffic is allowed, while other traffic is denied. Most times this is because of traffic filtering. First, you verify whether the telnet service is running by using telnet from R1 to :7. We didn't do that originally. So we're actually going to get onto our first hop gateway and try to telnet to our DHCP server, which is :7. And in this case, in our example that Cisco Press gives us, we're successful. Okay. So that helps us narrow down the scope of like where this problem could be, where this ACL could be. That's why we're doing this, right? Like if we couldn't telnet from R1 to the DHCP server to 7, if we couldn't telnet to it from there, then we'd have like the entire PC2 to R1 to :7 to have to troubleshoot and look for an ACL on. But we can see we're looking at what side of R1 basically has the ACL potentially, because we might have an ACL inbound on R1 facing towards PC2, or we might have one outbound going towards 7 on R1. We don't know. But the fact that we can send telnet traffic from R1 up to the DHCP server tells us that the ACLs, I'm guessing, probably on that ingress interface, gigabit 00, which you probably cannot read, but that's what it is, facing PC2. So anyway, let's see if they actually... Next, you check if there are any ACLs associated with interface gigabit 2/0 by using the command show IPv6 interface gigabit Ethernet 2/0. Oh, okay. So 2/0 on R1 is the one that's facing the DHCP server, not the PC. All right. So here's all our output. Up. Whoops. Do we see? I don't see an ACL listed. Okay, I don't see any ACLs on here on 2/0. So we're moving on. We're going to check 0/0. So we do the same thing, show IPv6 interface, gigabit Ethernet 00. By the way, nobody ever types out the full fucking interface name. I love that they always do this in examples because no one ever fucking does it. I type GI0 and then like tab maybe in real life. Anyway, show IPv6 interface. Boom, there it is highlighted for us. Inbound access list, NRC, right there. So it'll tell you. Now we need to verify the IPv6 ACL named NRC by using the show IPv6 access list NRC command. And then of course they have another example showing us this. So here it is right here, which you probably can't read, I'm guessing. I'm sorry. I could zoom in, but it cuts it off, you know? Anyway. So what do we have? We have denied TCP any host 2001 blah 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 :7 equals telnet. Well, that's pretty telling right there. The first one. Sequence 10. Interesting that the sequence number is actually for IPv6. It's actually at the end. I think that's funny. It's an interesting little difference. Anyway, is a deny statement that's preventing all devices from using telnet to get to that 7 DHCP server, right? So again, ACLs are processed from top down. So because that's the very first entry, that's the first thing that's going to happen. The first thing we're going to like try and match on for the traffic that's going through. And it's matching on any host that's using telnet towards our DHCP server. So, you know, traffic from our PC2 from :20 to :7, that's telnet. It's definitely going to match on this one. And it is a deny statement, which means that traffic is going to be discarded and we're not going to be able to telnet to 7. To solve this issue, we connect to R1. We enter into IPv6 ACL configuration mode for the ACL specifically called NRC, because that's what we saw was used inbound on that interface, right? Called it, by the way. And then you remove sequence 20 and add the same entry with sequence number 5. Oh, now that's interesting. So sequence 20, yeah, see, I keep making this mistake where I don't keep going down and reading it. I get really excited because I find the bad entry. Anyway. So our first entry, again, is denying any host telnet access to this DHCP server, but we do want to allow the PC that's having the problems to telnet, presumably, to 7, right? So they're actually saying this second entry, sequence 20, right under that denial statement, we have permit TCP host and then : 20. So that's actually permit TCP host. That's our PC that they're referencing right here, the : 20. Host : 7. So it's actually a permit statement designed for PC2 to get to our DHCP server equal telnet sequence 20. What? So this is actually the statement that we needed. This is the entry that we needed to match that traffic. This matches it. But since it comes after that deny statement, which is sequence 10, and this one's sequence 20, that's why we're not getting through. So we kind of just need to do a swapperoo. And unfortunately, you can't do swapperoos, official swapperoos, With ACLs, you have to delete the whole fucking entry and then you gotta put it back in with a number that is lower than the sequence number of the one that's causing all the problems, that deny statement. So that's why they're telling us right here, we need to actually go into configuration mode for IPv6 access list and RC, type no sequence 20. Hilariously, see, this is something that just blows my mind. I just, they had to make IPv6 just that much different. Could they not just make it the same configuration wise? Like, they had to make them just that much different that your brain goes, wait, shit, is that the right command? Anyway, so before, when we were deleting an access list entry, it was no 10, but now it's no sequence 20. Fucking stupid. Anyway, so IPv6 access list in RC, we delete sequence 20 by saying no sequence 20. Then we set it back up, but we set it back up as sequence 5 this time. So sequence 5, permit TCP host, :20, host, :7, EQ telnet. So there we go. Then to verify all of that, we do a show IPv6 access list in RC, and you can see our very first sequence now, sequence 5, very first entry, is permitting that telnet traffic specifically from that computer to the DHCP host. And that's it. And yeah, we do all the crap where we telnet to it to verify, but yeah, we're done. Hooray! Second ticket is done. Do I see real work on Reddit of all places? No way. Oh man. I didn't know network engineers were allowed to touch the application layer. Only for fun, not for professional reasons. Yeah, swapperoo is the technical term, in case you were wondering. It is the officially sanctioned term. There is an RFC that references swapperoos. Can't remember the number right now, but I'll get back to you. All right. Jesus Christ. The trouble tickets are good. They're really good. I complain about them. They're good to have. They're going to be a lot more complicated on the test, but they're good to practice, right? Just so fucking dry to get through. I just want to know how to intercept packages at a Starbucks cafe and keylog/redirect traffic to a clone site, asking for a friend. I'm not gonna fucking tell you, but you got IEEE in your username, so I bet you already know. Oh man, okay, this is my favorite part. This is my favorite part of Cisco Press books, okay? Is when we get into trouble tickets specifically, and they always have at least one trouble ticket where it starts with problem, a junior network engineer, insert shitty thing here. Like they always have at least one example that they give you where like a junior network engineer fucked up, and it's really fucking funny. Like it's really like, Jesus Christ, calm down, Cisco Press. You don't have to blame everything on poor junior network engineers just trying to do their best. Now here they have junior admin, but I'm still gonna count it because it's the same thing every time. It's either them fucking something up, usually that's what it is, or sometimes they'll just like ask a question and that's like the prompt for the ticket, right? It's really fucking funny. These poor imaginary junior network engineers. I'm just laughing because this one starts with problem, your junior admin has contacted you indicating that R1. All right, let me take a snippet. Hang on. Before we get too far. Okay, here's our snippet. You can see that. Okay. Problem. Your junior admin has contacted you indicating that R1, so on the left-hand side, that's the router on the left, R1 is not learning any routes from... I'm sorry, I have to laugh at this trouble ticket. I've been studying for too long. It's just, we start out with problem, your junior admin, blah, 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 and then And then, it goes on to like, they go on to write out the entire name of EIGRP as if I haven't already fucking studied that like 10 times in depth up to this point. As if anyone's gonna go through this, but I mean, like, maybe, but probably no one's gonna go through this book, like, and get to this point, like one of the last chapters, and not have studied EIGRP. Anyway, I'll get through it. I'm sorry. I'll get through it. Okay, here, I'm gonna read the whole thing. Problem, your junior admin has contacted you indicating that R1 is not learning any routes from Enhanced Interior Gateway Routing Protocol, or EIGRP, as shown in example blah blah blah. The admin has confirmed that neighbor relationships are being formed, interfaces are participating in the routing process, and other routers are learning about the routes. The admin has come to you for help, or admin, with your extensive knowledge. Sorry, this is the funniest trouble ticket. With your extensive knowledge, you ask your junior admin if he checked for any route filters. He says no. Yeah, fuck you, junior admin. You're a dumb fuck. All right, so of course. So we get on R1 and we ask R1, show IP route. And what do we see? We only see connected networks. We don't see any learned routes from routing protocols. So, okay, junior admin was correct with that. Then we execute the show IP protocols command on R1. So that's right below here. Again, I'm not sure if you can read it, and I'm sorry if you can't. But we do show IP protocols, and right here is where we're going to see the problem, right? Usually, if we've got a filter going on, this is what we're looking for. So routing protocol is EIGRP 100. And then right here, right under that, it says outgoing update filter list for all interfaces is not set. Incoming update filter list for all interfaces is prefix list filter such and such. So we do have an incoming filter, which is our prefix list. They were giving everything great names, and then suddenly they did some bullshit like this, filter underscore 10130. I guess that's specific enough to tell us what it's doing. It's not fun though. All right, so we see this filter right here on EIGRP. Next, we issue the show IP prefix list command on R1 to review that prefix list called filter underscore 10130. In this output, we can see that 10130/24, that prefix is being denied. So we can see show IP prefix list. Under the IP prefix list filter such and such, we have one entry and it says sequence 5 deny 10130/24. Okay. Your junior admin states that this is not the problem, because 10130/24 is supposed to be denied based on the documentation while all others are permitted. Aw, junior admin, you sweet, sweet summer child. You respond by saying that you're very sure that that is the problem. You remind your man, why do they have us like, it's like an RPG for like scolding young network engineers. It makes me really sad. Like roll 20 for intimidation, right? You remind your junior admin about how prefix lists are processed. Number 1, top down. Number 2, immediate execution upon a match. Number 3, implicit deny any at the end. Therefore, due to the implicit deny any, this prefix list denies all prefixes, not just 10130/24. Poor little junior admin. Poor little guy, he forgot about it. Is this a real question that can show up on a test, you ask me? No, this is the examples in the book. They're way simpler than what's going to show up on a Cisco test. This is just the beginning, baby. We haven't even gotten started yet. All right, to fix this problem, we just have to create another entry for that prefix list that permits all other routes. So we're going to have that fancy magical permit everything prefix entry. So IP prefix list, filter underscore blah, 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 sequence 10, permit quad 0/0 less than or equal to 32. And then we're going to show IP prefix list one more time to double check that we're good, and we're good because we have the deny here, and then right after our deny for the specific traffic that we hate, we have a permit all. Once we do a show IP route after that, presumably we've started sharing a few minutes later, a few seconds later, and boom, you can see the D's in this list, maybe not. I know you can see L's. I can tell that that's pretty clear. At least one L. Anyway, we have D's in the list. D's in the routing table tells us we're good. Yep, I'm not going to make the joke. You're welcome to. Hey, shit, we finished it. I'm so proud. Oh my god. You know, I've only got one more chapter. No, 2 more chapters left. Infrastructure security and device management and management tools troubleshooting. Infrastructure security, what are we looking at? iOS AAA troubleshooting. Oh, okay, radius and TACACS. It's been a hot minute since I did that. That's on Encore, the test I took before this. Troubleshooting unicast reverse path forwarding. I do not remember anything about that. Troubleshooting COP. Okay, COP is cool. And IPv6 first hop security. Well, shit, this is going to be a whole section of stuff I don't remember. Really? Sweet. Okay, well, we got some fun stuff for next time. Thank you for joining me on this horrible journey through hell, CCMP. I really appreciate your company and allowing me to hate on Cisco Press. I'm really sorry, Cisco Press and Cisco. You do good work overall. I just really like to make fun of you for no reason because I have to study your stuff all the time. Please be nicer to junior network admins and engineers. Please make nicer questions, nicer fake trouble tickets with where you're not shitting on imaginary junior admins and network engineers. Oh, now I get the questions. How long have you been studying? I my whole life. I've been studying for this test for like fucking 8, 9 something months. 8 months probably, my best guess. Maybe 7. Definitely more than 6. It's been a while. Somewhere between 6 and 9 months, we'll say that. Do you have any certs? I do have a CCNA, and technically, when you take the core specialization, what I took was Encore. It's one test, and it's 1/2 of the cert that I'm going for now, which is called CCMP. So technically, you get a certification when you pass the Encore or whatever core specialization you choose. So technically I have that, but no one gives a shit about it because it's new and nobody cares, right? Like it's half of a CCMP, that's all anyone cares about. So yeah, technically I have a couple, but officially really, as far as anyone cares, I just have a CCNA for now. Have you ever terminated a Cat6 cable? Yes. When did you first start learning about networking? Y'all really want to ask me the cool questions when I'm not, well, it's better than when I'm studying. When did I first start learning about networking? In 2018 in the summertime. So over 3 years ago now. That's when I learned what an IP address is. What's your opinion on CISSP? It seems really difficult. I don't know anything about security, and I don't really know anything probably about the subjects on CISSP. But I do have a partner in cybersecurity who has that, and it sounded like it was a difficult test. And, you know, really proud of them for getting that certification. So cool. Yeah. You know what, though, about the CISSP? I think you only have to pay to renew it like every so often. And I'm extremely jealous of that because with Cisco certs and vendor certs in network engineering world, as far as I know, you have to take the fucking test again to renew it. and I hate that. I'd really rather just pay some money to renew it, but whatever. How do you do in stats? Statistics? Are you asking about statistics? I took that in college once. I did okay. I do all right in math that's not calculus. I do okay. Is your router password your dog's name? No. You seem like a genius. Are you talking to me? I'm just reading straight out of a book. Doesn't require any brains for that. Anyway, I am mostly on RPAN for now. It's just easier to stream on here for the time being, even though, you know, RPN Studio kills my computer every time I fucking launch it. I'm moving into Twitch, but I don't know how to get the base yet for Twitch, so I'm just sort of like hanging out with a Twitch account, not streaming on it quite yet. I haven't put it up at the top here, but I do have a YouTube where I will be with also Track a Pacer, where I will be uploading recordings of these sessions. And I'm also on Twitter, as you can see up there as well. Please follow me if you want to just see the bullshit that I talk about. It's mostly just tech, just Twitter bullshitting about network engineering and stuff. But I always enjoy like seeing who's out there. We've got a cool network engineering techie community on Twitter, so it's really neat. Question, CCNP question mark? Yes, the answer is yes, CCNP. Oh, are you asking what CCNP is? It stands for Cisco Certified Networking Professional. You can Google it. It's a network engineering certification. You first learned what an IP is in 2018. Do you have a degree? I do, but my degree is not in network engineering. It is in English literature. When did you give up on your dreams of becoming a screenwriter to pursue the soul crushing job of network engineering? I gave up on all the soul crushing stuff from before to pursue my dream job of network engineer is really the answer to that. This is what I was meant to do, not anything else. Although I don't regret getting the English degree. I really don't. You know, most of us don't really know that much about what we want to do with our lives at that age. Well, a lot of us don't anyway, so I sure didn't. I'm good at reading and writing in the one language that I know proficiently, so you know, why not? It's not bullshit, you know, humanities degrees are awesome. You learn a lot of things. Particularly useful is critical thinking and text analysis skills, which no one seems to think are worth shit, but they're worth a whole fucking lot in life, in professional stuff, in every situation you could possibly be in. Other than like, you know, a Matrix style fight to the death, I don't think you're really using literary analysis in that circumstance, but pretty much everything else, I'd say it's very important to be able to think critically and analyze things. So I don't regret getting an English degree. It's just been an interesting journey to network engineering. I'll say that. What are you guys saying? I am not lying. I am not lying to anyone. All right, I don't know what the fuck y'all are talking about. Thank you so much for joining me. It's been great. I appreciate the interaction while I'm studying. It helps me like focus and not get up every 5 minutes. I'm pretty sure I have like undiagnosed adult ADHD, so you know, uh having people to talk to and interact with while I'm going through this boring, dry crap is really, really helpful. So thank you very much. I really appreciate it. Like I said, I'm on, you know, a couple different social media things and I don't have a regular streaming schedule. I don't know why you'd be interested in a regular streaming schedule for me at this point, unless you really want to fall asleep all the time. But yeah, I don't have a regular one quite yet. I'm working on it. I'm trying to figure out how to do all of the things. all of the things. Anyway, thank you guys very much. It was great interacting. I'll talk to you very soon.